Welcome back. We're now at lesson 9D. We are moving along, people. We are going to be through this semester before too long. We're going to be talking about a sensitive topic in this lesson, and please just be aware of that for yourself and for any others who may be listening in. And we're talking about real data, real events, but understanding it could be sensitive. So just keep that in mind. There was an article that you read in the preview, talked about when science goes wrong. I knew it was going to do it. And you read that and you learned about a proposed solution to SIDS was to shrink a thymus or the thymus with high doses of radiation. And these procedures had a high mortality rate and led to even more deaths when patients reached young adulthood. These operations were unnecessary and they had tragic consequences. Subsequent research has shown that these doctors were mistaken in their assumptions and that the thymus is not responsible for SIDS. In this case, there was a correlation between the size of the thymus and the occurrence of SIDS, but with additional research, it was learned that the enlarged thymus did not cause SIDS. Large note for your notes, for your flashcards, for your glossary, correlation does not always indicate causation. Can you think of two things that seem to be related where one of them does not cause the other one? If you've heard of something, write it down. And if not, we're going to be talking about some. Our objectives for this lesson are that we are going to understand that correlation does not imply causation. I don't think we can say that enough. We are going to be able to explain why, even if there is a strong correlation, a change in one variable really may not cause a change in the other. Statistical evidence is used to help make decisions about many things, some including medical procedures, legislation, educational programs. Just as it is important to learn how to collect and display data, it is also very important to learn how to interpret data. Question 2 gets us started by saying, considering the following statements and decide if you think one causes the other, or if there perhaps is a third factor that contributes to the two variables in the statement. This is the time to hit pause, take off on this lesson by yourself, and then check back in and we can work on stuff together. So beginning with part A. On part A, when someone says, every time I eat chocolate, it makes my face break out. Do you think that the chocolate is causing the face breakout? I jot down some thoughts, yes or no. And then jot down some thoughts on if you think there are other variables that could be causing these two to go together. Like, what if there's a lot of stress going on in the person's life? And when they're stressed, they eat a lot of chocolate, but at the same time, stress can cause acne. Maybe they're occurring at the same time, maybe they're not. But the question is it possible that there are more variables going on than just chocolate causing a face breakout? Looking at the next one, part B. A newspaper reports recent studies have proven that watching too much violence on TV is going to lead people to be violent in real life. Write down if you think yes or no or maybe. And also try to think of some things that might be additional variables that would impact this study. Because it may indeed be true that viewing acts of violence on TV can make you more susceptible to committing violence, but maybe increasing violence on television and increasing violence in society are both caused by changing economic circumstances or anything else you would like to jot down. Just think about these. A baseball player tells his friends that he did not change his socks for 3 games and the team won. all 3 games. Therefore, the player concluded that wearing these socks caused the wins and decided to not wear a clean pair of socks for the next game. Write down yes or no and maybe some outside variables, because just because 2 events occur together, even if it's once, twice, 3, 4, how many ever times, one event really may not have any bearing on the other. And it could be that this is just coincidence. So get out your flashcards or your glossary or a Google Doc, something, so that you can add this as a picture or underline it or put sticky notes on it. Statisticians have defined the correlation coefficient as a measure of correlation strength. The correlation coefficient can range all the way from +1 to -1. And it might even be good to think about this as money, that we can go all the way up to $1, all the way down to no dollars, and go in the hole $1. A correlation coefficient of 0 represents no correlation at all. But the closer you get to one of the ones, either the positive or the negative, well, when you look at this first one, these dots are just all over the place. There is no correlation. When you look at the second one, it's almost like they are trying to make formation. We live around a bunch of hurricane activity, and we talk about formation of the hurricane. It's getting more defined. This is getting more defined, maybe more close together, but it's still very weak. The next one is still weak, but it appears to be trying to go in a positive direction or a positive correlation. This one appears to be negative and weak. But these last 2, this one appears strong and positive. This one appears strong and negative. Again, hit pause. Go ahead and work on questions 3, 4, maybe all the way up to 5, and then come back and we'll work on them together. Question 3 says, determine whether the correlation would be positive, negative, or 0 between the variables in each of the statements below. Starting with part A, the carbon dioxide levels in the atmosphere since the 1950s and obesity levels in the United States since the 1950s. Write down your thoughts, your opinions. It does seem, though, that the carbon dioxide levels have gone up, and it does seem that obesity has gone up. So with both going up, that would be positive correlation. What happens, or what do you have correlation-wise? The height of school-age children measured in inches, the height of school-age children measured in centimeters. So if you look at the height of the children, if you measure it in centimeters, their height, as the height goes up, the centimeters are also going to go up. With also, sorry, I skipped the inches first, the inches too. And in fact, not only is this going to be correlated, it's going to be positive, and it's going to be identical, because we can convert these to the same amount. We can convert them back and forth to each other. It's going to be a perfect positive correlation. And finally, if we're looking at part C, the age of a particular model of car and the value of the car. Remember, we've talked about if we have time, we put it on the x-axis. So if we're looking at the age, 1, 2, 3, 4, 5 years, here's age on the x. And then the value of a particular car. It depends on if you're talking about antiques or not. We'll just go ahead and talk about regular ones, but the value, it's going to start here and it's going to go down over time. So it does appear that we have a correlation, and it would be negative because as the age increases, the value decreases. It's time to hit pause again, do question 4 or questions 4 and 5, and then come back and we can work on these together. Question 4 is talking about a statistics teacher was sitting on a bench overlooking the ocean, eating an ice cream cone, and a student in one of his sections sat down next to him and said, "You better be careful. There is a high correlation between eating ice cream and drowning. The teacher was in the middle of a big bite and looked a little confused, so the student elaborated, "Don't you know that the days with the most ice cream sales also have the most drownings? So therefore, do you think that eating ice cream causes drowning?" Write down whatever you think, but very likely there are some outside variables, like maybe temperature. And as temperature goes up, people are probably eating more ice cream. And as temperature goes up, probably more people are swimming, which can increase the likelihood of drownings. Moving on to question 5. It says data were collected on the weight of cars and their gas mileage. So looking for just a second. Pounds, highway. And so I've got to go ahead and put this in my brain as to what's going on, or at least get me started in a good direction. Pounds and MPG. Very likely, the pounds of a car will impact the miles per gallon that you're getting. Probably the heavier the car, probably the less you're going to get with miles per gallon. So probably as the pounds go up, probably the miles per gallon go down. Part A says create a scatter plot. I'm going to use this one that's already created. And notice that in the weight, it starts at 3,000. It doesn't start at 0. It goes up to 5,000, so that's very acceptable. It'd probably be better if they showed us that on the graph, but we'll point it out. And then the miles per gallon actually start at 14 and go up to 30. When you look at the scatter plot, look at part B. Does there appear to be a correlation in the data? And if so, is it positive, negative, weak, strong? Write a contextual sentence about the correlation if there is any. And yes, there does appear to be a relatively strong negative correlation, indicating that the more a car is weighing, then you're going to tend to get lower gas mileage. Looking at question part D, actually part C, it says name some other factors or lurking variables that might also affect the gas mileage of the cars shown. Jot down your thoughts and experiences. That might include style of the car. It could be a sports car. It could be the design of the car. It could be aerodynamics, good or bad. It could be any other factors that you think will impact what we're seeing here, that the weight is causing or impacting the miles per gallon. Part D asks us to pick any two ordered pairs from the table, find the equation of the line that passes through those points. We can use Excel, but I'm going to go ahead and do this one by hand to get us another look at how that's done. And pick any 2 points. So it doesn't matter. Let's pick the first point, and this point here, it's got a 20. That looks like a pretty number. If we are talking that this is X and this is Y, our slope formula is still going to be, and I would encourage you to write down the entire formula, and I'll go label these as X1, Y1, X2, Y2, and I'll start plugging in the information. Like I'm getting 20 minus the 28 over 4289 minus 3489. So I'll grab a calculator. If you're not comfortable with the integers, you can do 20 minus 28, either by hand or on your calculator. And then you've got 4289 minus 3489, and we're getting 800. So when I divide my 8 by 800, I get a negative 100th. To do the equation, I'm going to need y equals mx plus b. I don't have b right now, so I'm going to go off on the side. We talked about this on video and in class, that when you go off on the side, you're going to use one of your points, so this one or that one, and you're going to plug them back in, but this time with the slope you just calculated. So I'll go to the first one. It doesn't matter, pick a point. So I'll use the first point. So in y equals mx plus b, I'm going to use my y of 28, my m of 348. Oh, I'm already messing up. Sorry. So I have 28, which is the y right here, equals m is what we just calculated, x plus b. We're going to multiply these two together, and I'm going to have 28 equals, so let's take 0.01 times 3489, and again, either take care of the integers or the signs in your brain or on the calculator, but this is a negative 34 and 89 hundredths plus b. We have one last thing to do to solve this equation, and that's to add our 34 to both sides. So we're ultimately getting, I'm going to move it all the way down here, that our b is worth 34 and 89 hundredths plus 28. It says we're going to go through the y-axis around 37. And so now to finish off our equation, we have y equals the slope and the x, and now we can put back in, we can put in, oh, and I'm out of room. We can put in the intercept we just found. So we now have an equation as it asked for on part D. Part E then asks us to take our equation and find the miles per gallon for a car that's going to weigh 2,269 pounds. So I'd even like to make this a little bit better, and instead of Y, call it like M for miles per gallon. And instead of X, maybe call it P for pounds. And they just gave us some pounds. And so we're going to, I'm going to go ahead and go to that screen. And in place of P, I'm going to put the pounds. So working part E, I'm going to transfer the equation we got on part D, that the mileage, miles per gallon, is the formula we came up with, times the pounds, and then add in the y-intercept. They're saying if the car weighs this, then let's go find the miles per gallon. So we're looking for the miles per gallon. We need to take the slope. We're going to multiply it by our pounds. We're going to stick that in for P, and then add in our y-intercept. I'm going to grab calculator. I'm going to punch in 0.01, call it negative, and then times 2,269, and I'm getting a, let me try that again, 0.01 times 2,269. I like that number better. It didn't look reasonable. So I'm getting a negative 22 and 69 hundredths. I need to add in the y-intercept, so I will add in, and mine, okay, 22 and 69 hundredths negative. I'm going to add in 36 and 89 hundredths, and I'm getting that our miles per gallon would be 14.2. Part F says go to the following Motor Trend website, scroll to the bottom, and let's see what's going on with this Mazda. So part F asks us to go to this website, scroll all the way to the bottom, and see how we did as far as coming up with our equation. And I looked here and I see that they've got 29 and 35, 29 city and 35 highway, and I'm thinking, wow, our answers are really not even close to that. And so I went back and looked at my work, and everything looked good right here, finding the slope. And then when I got over here to, and then back to question 5, and I added my 34, somehow I didn't think about reasonableness, because if I go back right here and I add these two together, it is not reasonable that 34 and 28 would turn out to be a 36. So I'm going to hit clear a bunch of times on my calculator and go ahead and do 28 plus 34.89, and wow, that number comes up to be different. So I have a mistake. So it's not 36, it's 62.89, and that's going to impact the answer that we got on the last question. I'll need to go find which one that is, a part E. So I'm going to go back and redo part E. So here I am back at part E, and I apologize for making the mistake. I don't like to confuse me or anybody else, but I need to go back and fix this. So looking at part E, when I was writing this down, I wrote this part wrong, and it needed to have been, using our 2 points, 62 and 89 hundredths. So I would still plug in the 2,269. I just need to make sure this is 62 and 89 hundredths. I would still multiply these two together, but I would not be adding in the 36. I would be adding in 62 and 89 hundredths. 14 is pathetic, and this little car is going to get a lot better than 14. So grabbing calculator again, I'm going to type in 62 and 89 hundredths. Let me start the other way. I'm going to start with 22 and 69 hundredths, a negative, and add to it 62 and 89 hundredths. And boy, that looks a whole lot better. So we get an answer of 40 and 2/10 miles per gallon. Now on part F, it does ask us to go look at this website, and under the Mazda 2, it does say the EPA fuel economy is 29 in the city, 35 on the highway. I got 40. I was using only 2 points. If we had put this in Excel, which would have calculated all the points together, it would probably be a little bit tighter answer and closer to those. But I'm much happier with 40 than the 14 I had the original time. On part G, it asks us to interpret the slope and the y-intercept of our equation in context. So eventually, this is what we got for the slope and y-intercept. And this is what we were calling miles per gallon. And this is what we're calling P for pounds. And so I really like to see this as a graph, that our pounds, as they increase, in miles per gallon should be decreasing. But this one specifically says, let's talk about the slope and the y-intercept in context. So I'll start with the y-intercept. The y-intercept is at 62. And the y-intercept is saying, if the car weighed nothing, it would get 62 miles per gallon, which is nonsensical that the car would weigh nothing, it would be non-existent. But in context, if the car could weigh nothing, it would get 62 miles for every gallon that this non-car would go. The next piece says slope. One thing I keep talking to you all about is writing down that slope is the change in y over the change in x. So it's going to be the change in our miles per gallon over the change in our pounds. And if that's the case, we have a slope of this number, and I like to go ahead and write it over 1, because then it really does help my brain to realize this is miles per gallon and this is pounds. And then I really like to pronounce it starting with the denominator, that for every increase, in other words, for every pound we go up, we go down 1/100th in our miles per gallon. Or you could say we're going to go down 0.01 miles per gallon for every increase of 1 pound. Write something that makes sense, that you like, and then part H says, let's compare what's going on to part B to what we just got in part G. So when I look back at part B, we were asked if there's a correlation. And we said that there's a relatively strong negative correlation, that cars that weigh more tend to get lower gas mileage. And looks like we're spot on, that the correlation was negative and the value of the slope is negative. So strong or not, we can look at that further later, but right now I think we're doing right. We found out or noticed that it looked like it was a negative correlation, and we got a negative slope. So for every bit that our car is gaining in weight, it is decreasing in miles per gallon. This finishes lesson 9D. Look at your syllabus to see if you have more to do this week, to more lessons that are due at our deadline this week.